第51集电磁铁。
Hi, Meng Meng. What are you doing?
嗨，克里斯博士，我在把这根针磨成磁铁呢。我要把这根针变成指南针。
So you've mastered the magnetic force. Very impressive.
没错，爸爸妈妈也被我的物理知识震惊到了。我还懂电学知识呢，你知道的。
That's great, Meng Meng. But did you play the game that I left last time?
你是说把钉子变成磁铁的那个游戏吗？
Very good. So now you know magnetism and you know electricity. But what did you learn from the game?
我现在学会用2种方法来做磁铁了。我不仅学会了用磁铁磨针来做新的磁铁，还学会了用电池和绕圈的电线来把钉子变成磁铁。
Well, yes. But that is something that you did. Can you think of the lesson? Can you apply this knowledge to something new? That is the mark of a great scientist.
好的，我也能成为一名伟大的科学家，但是怎么能把这个知识用来发明新的东西呢？让我想想，这太难了。
Well, did you know that scientists use their understanding of electricity and magnets to create the first motor? Following that came cars and even planes.
哇，用磁铁和电来发明电动机，太棒了！科学家们是怎么做到的呢？
The key understanding that they used was to turn electricity into a moving magnet.
把电力变成移动的磁铁，太神奇了。
Yes, it is an amazing invention. Scientists learned long ago that electricity and magnetism are very close. So now you know that electricity and magnetism are very closely linked. In fact, they're the same force, the electromagnetic force.
哇，同一种力。
That's right. Sometimes it's hard to detect. The best physics happens beyond our senses. The world is such an amazing place.
我同意，我从你那里学到了好多呀，克里斯博士。
Well, that's because you are very hardworking and you ask lots of questions.
是的，我现在就有一个问题，你说电力和磁力是同一种力，为什么呢？是因为磁铁和电荷一样能相互吸引吗？
Yes, they do. In fact, it's okay to still think of electricity and magnetism separately, but always remember that they come together.
一起出现，它们就像是一个家庭吗？
Good way to think about it, Meng Meng. They're all a part of the electromagnetic family. So children, would you like to know how motors were invented? Would you like to know the amazing part of the electromagnetic family? Follow me. Hi, children. Do you still remember the field?
就是农民伯伯种出我喜欢吃的美味大米的农场。
No, the physics field that creates the force. It's the field that surrounds every magnet.
啊，对，我想起来了，叫什么场来着？
The magnetic force field.
哦，对，磁力场，这个场是存在于每一个磁铁周围的磁场。
That's the one. The field is all we need to know the force a magnet will feel and where it will be pulled.
所以科学家们很想找到这个场了。
That's right. Scientists, when they're looking at magnets, focus on this field. Now, we haven't talked about this yet, but the electric force is also caused by a field.
电力也有场，电力的场和磁铁的场一样吗？
Yes, they are. The electric field and magnetic field are very similar. And, by the way, Meng Meng, did you know that every force has a field?
每一种力都有场。
Yes. And though we cannot see or feel the field, they exist all around us for every kind of force.
你的意思是，我们今天开的汽车和坐的飞机，都是在科学家们了解这些场之后才发明的？
Oh, you're so clever, Meng Meng. Scientists figured out many years ago after study that the electric and magnetic field were very closely related, and they used a very simple equation to show it.
数学等式就像1加1等于2，还有像牛顿力学的那种等式吗？
That's right. But these equations use some special mathematics to keep them simple. Maybe you've heard of it. It's called calculus.
微积分，这是一种什么样的数学啊？我好想知道。
Well, I'm going to have to teach you about this later. For now, let's take small steps to help us understand. In fact, there are a few tricks I know. This is how scientists and engineers can make use of mathematics and deep physics knowledge.
科学家们会有小窍门，怪不得他们能做那么多了不起的事情。
Yes. So, would you like to know the trick that tells us the secret ties between electricity and magnetism?
哦，当然了，克里斯博士，快告诉我们吧。
Great. It's called the right hand rule. And all you need is your right hand.
只用右手，这个我当然能做到了。
Okay. So, you need to remember 2 gestures. The first is like this. And the second is like this. Do you think you can remember these 2 gestures? Dr. Chris will help you practice and will reveal the secret behind these 2 gestures now. Children, I just showed you the gestures you need for the right hand rule. Let's start with the first.
这个我能做。
Good! You can think of your fingers as arrows pointing in 3 directions. One direction is the direction an electric charge moves. Another direction is the direction of the magnetic field. And the last direction will tell you the force that the magnetic field pulls on the charge with.
可这是什么意思呀，克里斯博士？快告诉我们这个手势的意思吧。
Okay. The right hand rule tells us that a magnet can attract an electric charge. And it tells us where the charge will be pulled.
哦，我懂了。那这3根手指所指方向都代表了什么呢？
Okay. So the 3 directions are as follows. This finger tells us the direction that the electric charge is moving in. This finger tells us the direction that the magnetic field is pointing in. And finally, this finger tells us the direction of the force that is pulling on the electric charge.
哦，我明白了，这个手指是电荷的方向，这个是磁力场的方向，然后最后这根手指是磁力场吸引电荷时用的力的方向。
Very good.
哦，你的意思是我用这个手势就能判断出电力和磁力是怎么在一起的吗？
Yes. What a great trick. But I urge you to remember which direction means what. Otherwise, you might end up pointing in the wrong direction.
哈哈，那样的话可就糟了。第2个手势所代表的也是同一个定律吗？
The second right hand rule is very similar, and it really shows why electricity and magnetism are a good family. Do you remember the gesture?
我呢是个竖起的大拇指的手势，像这样。
That's right. Now this gesture can show two things. The first is where a magnetic field will point when a charge moves. Imagine an electric charge moving in the direction of my thumb.
一个移动的电荷，就像是电线里面的电流那样吗？
Yes. If a current moves in the direction of my thumb along a wire, then the direction of the magnetic field is the direction of my fingers.
围绕着电线周围的磁力场吗？
Very good. And the right-hand rule can tell us the opposite as well. This time, imagine my fingers as a coil of wire with electricity flowing in the direction my fingers point.
盘绕成圈的电线，哦，就像我们做的游戏，将电线缠绕在钉子上，像一条通电的蛇一样。
Electric snake? Whoa, that's a scary thought.
这个是蛇头，也是电蛇的前进方向，是不是？
Yes. So in this case, the current of electricity creates a magnetic field in the direction of my thumb.
让我想一想，电一圈一圈的流动，形成了磁铁。哦，原来这就是为什么那根钉子会吸住金属的区别针啊！
Right. I mean, right-hand rule.
这个窍门太了不起了，它还能解释什么别的吗？
Oh, so you think you're ready for the final test?
是的，克里斯博士，我是个了不起的科学家。
Okay, let's go.
亲子游戏。
Hello, children. Today we learn how electricity and magnetism form a very close family. Whenever there is one, the other is always there, but sometimes it's hiding. The right-hand rule was a good trick for explaining why electricity and magnetism work together to create forces on electric charges. Today, we're going to test your knowledge with a fun game. In this game, you'll need a battery, a magnet, and some wire. Now, the magnet will stick to the battery because the battery is made of metal. Have Mom or Dad twist some wire for you so that one side touches the top of the battery and the other side touches the magnets. Now place the wire on your battery. Whoa! Look at that! Can you explain it? That's your test. Next time, we'll reveal the answer. Until then, have fun creating new shapes and watching them dance with electromagnetism. Bye!